Today's plenary lecture will be held by esteemed Ayelet Baram Tsabari, and the chair of this session is going to be the ESERA President Sibel Erduran. She will go into better detail for the introduction. So the floor is yours, madam.
Good afternoon, everyone. Welcome. The last time I stood on a stage like this, behind a podium where hopefully most of you can see me, I have this running joke about being seen behind a tall podium, was in Bologna 4 years ago. Isn't it wonderful just to be here in the same room, in the same physical environment? It's wonderful. Welcome, hoş geldiniz, shalom, galimera, bon dia, buongiorno, guten Abend. We have 55 languages or so represented at this conference. I cannot possibly use them all, but you get the point. This is the diversity of ESERA, and we're happy that you're here, emerging from the pandemic. First time we're doing our conference in the last 4 years in person. Make the best of it, is all I would say. As Gültekin said earlier, it's really important to get to know each other, to make new networks, to make new friends. Could I just ask first-time participants of ESERA conferences to raise their hands? Wonderful, welcome. If you have seen, could we just raise those hands again? Please make sure that you say hi to those people, so those of the senior people. Just say hello, welcome them to the ESERA family. Of course, this conference wouldn't be possible without a lot of tireless, countless hours of Zoom meetings since we started this event organization years ago. The local organizing committee, led by Gültekin Çakmakçı, Fatih Taşar, Mustafa Hilmi Çolakoğlu, along with the support of their universities, our current university, and to other universities represented, as well as the ESERA board, have been working tirelessly. The strong coordinators, the reviewers, you yourselves have been working tirelessly to make it happen. And without your participation, we wouldn't be here. So thank you, everybody involved in the organization of the content of the conference. Of course, we have very distinguished guests here today, and I think their participation is an endorsement of the role of science education in society. And I would like to pay a special thank you, teşekkürler, to our minister, to our governor, to our rector, for honoring our conference by your attendance here. This is really much appreciated. It's important that our policymakers and politicians are involved in research activities of science education to ensure that science education is relevant, as Ayelet will soon will be talking about. I want to say a few more words about the organization of the conference, which started taking place 2 years ago, and obviously due to the pandemic has been challenging, to say the least, because we may have had an online conference, a hybrid conference, a physical conference, back to lockdown, back to this new way of doing things. So our colleagues have worked in very extraneous circumstances, but I want to also acknowledge one other factor, which was the earthquakes in Turkey in February of this year. And I'm sure that there are our Turkish colleagues here who might have lost loved ones, relatives, friends, colleagues. Our heart goes out to them. Condolences, geçmiş olsun, to all the victims of the earthquakes of February 2023. I know that our local organizing committee worked on this conference, on planning of the conference under really extreme circumstances following these devastating earthquakes. So I would like to acknowledge this as well. Right, so The fun begins with the conference, to make new friends, to learn new ideas, to get to know each other, and to actually interact in person, to develop new relationships, new professional relationships, and to enhance also not just your research career, obviously, but to contribute to research in science education, and with an effort to potentially impact policy and practice of science education. So I couldn't imagine having a better theme to start the conference than with Ayelet, Baram, Tsabari's presentation on the relevance or lack of relevance of science education to science-informed behavior in the context of COVID-19. So I'm going to briefly introduce Ayelet from the Technion, from the Israeli Institute of Technology, to give you a sense of her background. She is a former science journalist, science communicator, a professor of science education and communication at the Faculty of Education in Science and Technology at the Technion Israel Institute of Technology, where she heads the Applied Science Communication Research Group. She was an elected member of the Israel Young Academy, the scientific committee of the PCST network, Public Communication of Science and Technology. I think this is a really critical issue at this point in time, as we've seen with the pandemic context, which Ayelet will elaborate on. The public understanding of science has become even more important given our context. She is a PI of the Research Center on Taking Citizen Science to School and of the Research Collaboration Public Engagement with Science in this era of artificial intelligence. Her research program focuses on supporting public engagement with science and effective science communication. She was awarded the Marie Curie International Outgoing Fellowship, and recently she received the Higher Education Award for a young faculty member for an exceptional contribution to society and the communication in Israel from the Council of Higher Education. Baram Tsabari hosts a science communication MOOC at edX and serves as an editorial board member on the journals Public Understanding of Science, Science Communication, and the International Journal of Science Education, Part B. So please join me in welcoming Ayelet to the stage to listen to her relevant talk. Floor is yours.
Hello, marhaba, shalom to everyone. Thank you for inviting me and thank you for being here. I would like to start with a story. Let's go back to 3.5 years ago, to the beginning of March 2020. On March 4th, 2020, the Ministry of Health in my country came out with this unheard of guideline. Anyone coming back from Italy or Spain in the last 14 days should be self-quarantined. Okay, this is a really strange idea, and many people were affected, among them the Maccabi Tel Aviv basketball player team, who just came back 12 days ago from Valencia. And they found out that they're supposed to go into self-quarantine for 2 more days. But they didn't want to because that evening they had a game against Anadolu Efes. So they didn't go into quarantine. Instead, they won the game, sorry, Giltkin. And the next day, they took the plane and went on to play against Red Star Belgrade, which turned out to be the last game of that season because of COVID-19. And while this was happening, many people who usually don't care at all about science or don't see themselves as people who care about science at all were contemplating, should have the players self-quarantine or not? So in an online survey we disseminated while this was happening in Israeli sports fans forums and Facebook groups and websites, we asked people, do you think the Maccabi Tel Aviv basketball players should have self-quarantine after returning from Spain, and also why? So what do you think the sports fans said? What do you think? They thought the basketball players should have or shouldn't have self-quarantine? Shouldn't? Okay, so keep that thought in mind. We'll find out very soon But this is the theme I want you to have during this talk. So what happens when a science-based issue or a health-based issue actually meets the real world, okay? Actually meets public understanding, public engagement with science. So today we will first start with the assumption that science education actually helps people while they're engaging with science in their lives. We'll see some theoretical and empirical gap regarding this assumption. I'll tell you about my research approach. I'll depress you to death with some empirical evidence. Then I'll give some optimistic empirical evidence, and we'll wrap up with some implications for science education research. Okay, let's start with the assumption. Science education in recent decades has become mandatory for students, all students in many, many countries, under the assumption that it has some value for their lives outside of school, not just for the people who are going to be scientists later on. I would say that the communal disciplinary worldview is that science literate individuals make better, more logical, more informed decisions. And if we look at the different rationales that have been offered for science literacy, we usually find four big values for science literacy. One is the economic, this idea that scientifically and technological skilled population is needed to stay competitive. The second is cultural. So science is one of the greatest achievements of humankind, and it provides new glasses, new way of seeing the world. The third is democratic. So citizens in democracy or not in democracy participate directly and indirectly in decision-making about science-related policies. And the fourth is a personal rationale. So this idea that science literacy helps people respond to issues and challenges in their personal and community context. Let's think about these four values. The first one, the economic one, really focuses on preparing professional technological workforce, not on everybody. The cultural one is really not unique to science. It's in a similar way, this is true for literature or history or art. The third one, the democratic one, is of course very important, but it functions at the national and an international governance level and involves many stakeholders, many experts and politicians. So it's really hard to say that because the citizens had another year of schooling, something happened. That brings us to the fourth rationale, the personal one. This rationale considers science and technology to be intertwined in the lives of people in the 21st century. And it's the idea that we need some grasp of science and the ability to interact with it because it helps people to make better decisions and engage in informed actions that can lead them to have richer and healthier lives. So what is personal usefulness? I will use here the words of Nochwitz Feinstein. These are instances where science education can help people solve personally meaningful problems in their lives, directly affect their material and social circumstances, shape their behavior, and inform their most significant practical and political decisions. What I'm not talking about when I'm talking about personal usefulness, I'm not talking about STEM careers. I'm not talking about using math education as a gatekeeper for something else. I'm not talking about cultural capital, so someone thinks I'm smart because I took physics. Not about that. I'm talking about instances where science education actually helps me in my decision-making. Now, the personal usefulness of science education is a really very strong shared assumption in our community. Just to give you one example, this is from the OECD's framework for assessing science literacy in PISA in 2017. And it reads, given that knowledge of science contributes significantly to individuals' personal, social, and professional lives, and understanding of science is thus central to a young person's preparedness for life. Okay? And I find it really ironic that there is so little evidence for that given that science education helps people make evidence-based decisions. It's like we don't need the evidence that science education supports evidence-based decision. In a way, we're going around with these hypothesis in our minds that more years of formal science instruction or formal science instruction focused on developing science literacy or instruction in reasoning from evidence, all these translate somehow to helping people engage more successfully with science, well, compared to people who didn't have this type of instruction. And my question to you is this a given? Don't we need to have some evidence for this hypothesis? So that was the assumption. Let's look a little bit about the theoretical and empirical gap. Education is ultimately about the transfer of what was learned within class to other contexts, to new contexts. Or in the words of Brunner, learning should not only take us somewhere, it should allow us later to go farther more easily. I like this citation. So education is ultimately about transfer, but with the exception of modest and isolated gains in conceptual knowledge, it is not clear that these campaigns for science literacy have enhanced people's ability to function in a world where conflicting health advice clutter the internet, research is filtered through political screens, and the media strip context from scientific claims. Or even stronger words, it appears to be a matter of faith among policymakers and researchers that high-quality science education will result in producing students, and therefore citizens, who can successfully navigate science-related civic issues as they arise later in their lives. So when I'm thinking about personal usefulness, I'm thinking about transfer, about cases in which science education becomes useful because people identify it as relevant to their needs and choose to use content or practices or scientific dispositions that they learned in science education to make sense of novel science-related situations in an effective way. However, most of the time in the real world of public engagement with science, our content, knowledge, and the practices we have are really not enough to decide anything. So we are dependent on factors outside of our cognitive agency. Just to give you a really simple example, I guess all the people in this auditorium would say the Earth goes around the sun and not the other way around, but not that many people. Well, let's ask, who knows to explain why we know that the Earth goes around the sun and not the other way around? Can you raise your hand? Okay, so we have like 20 people in a science education conference, okay? And I would imagine that even those 20 people, they didn't do the data collection, they didn't do the data analysis. Somebody told them that, they read it somewhere. Okay, so this is epistemic dependence. People cannot avoid some epistemic dependence on experts. Non-scientists, these are the words of Stephen Norris. Non-scientists' belief or disbelief in scientific propositions is not based on direct evidence for or against those propositions, but rather on reasons for believing or disbelieving the scientist who assert them. Or in the words of Brome and Goldman, the ability of lay people to reach informed decisions is usually not based on first-hand evaluation of what is true, so is this proposition true, but rather on a second-hand evaluation of who knows what and whom to trust. So for me, science education becomes useful if people identify when to trust their own science knowledge and when to trust experts, and when they need to make sense of novel science-related situations in their lives. So what I'm trying to do here is to bridge these two worlds of research that have so much in common, but somehow do not speak enough. And that would be science education with its concept of science literacy and science communication with its concept of public engagement with science. And I'm working on this bridge built by other scholars, of course, like John Dewey and Edgar Jenkins and Noah Feinstein. And I'm trying to synthesize a new understanding of science education in the lives of non-scientists who are faced with science-related decisions. Because these two concepts have very different glasses or use very different glasses to look at the world. While science education makes really an optimistic assumption that if we teach science properly, in a good way, people who encounter science in their everyday lives can acquire knowledge to make informed, scientifically based decisions. This is like a very optimistic assumption. But empirical evidence from the field of public engagement with science indicate that people derive meaning from the science they encounter in their lives using different narratives that might or might not include science at all. So let's talk a little bit about public engagement with science. First of all, we all have limited understanding of science. So the public's limited understanding of science leads people to make science-related decisions primarily using heuristics. And this phenomenon is called bounded understanding of science. So just to give you an obvious example, when I'm told that activating the particle accelerator in CERN might cause a black hole that might annihilate Earth, I don't have any way of learning, any reasonable way of learning the physics and checking for myself. Is that true? I mean, even if I spend a few years now, I probably don't know if it's true. So I need to trust some people who tell me that it's true and not trust other people who tells me it's not. Public engagement with science really works in a local context. Somehow scientists and science educators assume that scientific knowledge by itself can solve real-world problems. But really, science-related problems that people encounter outside the classroom or the lab demand a form of contextualized rather than abstract knowledge. So if you're not MacGyver or you're not making drugs, depending on the decade you were born, you would emphasize more. Then usually, abstract scientific knowledge are not that useful in your life. Also, knowledge of science is not enough and may not even be of the greatest relevance to our decisions. The blending of scientific and non-scientific knowledge in context-specific ways is essential, really. It's not a noise in the system that we need to filter. It's rather a reality to be expected. And also, even when the science is known and clear and the people know this science, even then, people might prefer to take a different course of action since the decision plays out in a social context with socially relevant outcomes, as any teenager who needs to decide if to drink and drive knows. So what did we do about this? Let me just paint the research approach. Generally speaking, the question that drives my research in the last few years is what is the usefulness of science education for adult engagement with science? So really generally speaking, we can imagine that the independent variable would be highest level of formal science instruction, and the dependent variable would be adult engagement with science in a personal context, okay? So there's many challenges to this, but two big challenges are attributing the difference in the dependent variable to learning experience in science education. So it's not something else that caused it. And two, to define and measure what is successful public engagement with science, which is really ill-defined. So luckily, we could use a natural experiment capitalizing on diversity in our society, because we have the ultra-Orthodox Jewish communities in Israel. It's a significant minority that has a segregated schooling system. And Haredi school aim to prepare children to their gendered role in society, to assist boys to become religious scholars, and to prepare girls to support their husbands while they're becoming religious scholars. So actually to bring the salary. So STEM is really not emphasized. Haredi women could study science up to the age of 15, but boys rarely study science or math beyond 5th or 6th grade. So that would be 11 or 12 years old, as this is perceived as unnecessary knowledge for the life of a pure scholar. Now, you might be thinking to yourself, okay, why is she telling this really ridiculous story about this minority in a faraway country? Who cares about them? I would like to say this is not that uncommon. So apparently in 2014 Eurobarometer, 43% of Europeans said they never had any science education, not in school, not in university, and not anywhere else. What you see here is the total yes. So these are the countries that had extremely high or extremely low percentages of people. So the second main challenge was to define and measure successful public engagement with science. We use as a conceptual framework this three-dimensional thing you see here. So basically, looking both at epistemic criteria and non-epistemic criteria, process and outcome, and externally evaluated and internally evaluated criteria. What I will show you today is only externally evaluated and mostly epistemic criteria of process and outcome. And we used contextualized performance tasks embedded in surveys. You'll hear more about it in a second. And then came COVID-19. So the COVID-19 pandemic really provided an appropriate context for empirically studying this question because it exposed all the population to the need for science-related personal decision-making, not only the people who are interested or educated or care about science. And in this heterogeneous Israeli context in which I worked, it also included a significant minority that didn't have almost any mandatory science education. So brace yourself. We're going to see now some really depressing empirical evidence, okay? So the first question was, do people who learn more science make more science-informed decisions? And you see here, Yael Rosenblum was a PhD student that was involved in much of the data collection and analysis. So in a series of surveys of Hebrew-speaking adults, we presented participants with authentic and timely dilemmas concerning social distancing during COVID-19. How did we measure science-informed behavior? We used a few measures. One was adherence to social distancing guidelines or recommendations, whatever it was, based on culturally adapted dilemmas as a measure for recognizing and accepting experts' consensus. So things like the number of guests in a wedding, visiting elderly family members, sending one's child to school after sharing an elevator with a verified COVID-19 infected individual, okay? The second thing we looked at was justifying the chosen behavior. So how people justified what they decided. If they used health or self-related arguments, we saw that as a measurement for identifying science as relevant to the issue and using relevant scientific knowledge. So we asked people, if you had to convince your parents or spouse, what would you tell them? What arguments would you use? The third was choosing credible information sources as a measure of the capacity to make evaluative judgment about the source expertise. So we asked people, if you could consult with someone regarding this decision, who would you consult with? What sources of information would you turn to? We also measured knowledge. First, we measured general science knowledge. That was, here we used statements from, you know, the science and engineering indicators in the US. They use it since 1979. So statements like antibiotics kill viruses as well as bacteria, false. It is the father's gene that decides whether the baby is a boy or a girl, true. And also a question that asks people to apply the concepts of a control group and placebo. The second thing we did was to measure science knowledge in the context of COVID-19. Mostly we did it using this question. Anyone who encounters a verified patient for COVID-19 must self-quarantine until 14 days from the encounter passed. Okay, it depends on how many days it was at that time. Even if the person exposed has been going about their regular business for several days, would self-quarantine help at this point, and why? And then we manually coded all the answers, and a full answer addressed reducing exposure, the incubation period of the virus, or the carrier may be asymptomatic. And we also looked at using science concepts correctly, the number and the level of the concepts, and if they use them correctly. Okay, we had 3 samples here. One was a representative sample of the general population. The second was ultra-Orthodox Jews collected by phone because not everybody used the internet. And the third was a convenience sample of sports fans collected via online questionnaires. You already heard about them. Okay, what we see here. This is a correlation between demographics, demographics, you want to move, and knowledge indicators and behavior. And are these correlated with the highest level of science education people had? And you can see here that science education indicators played only a minor role in explaining individuals' adherence to social distancing guidelines. So, of course, science education was correlated with general education, but this is choosing credible sources. You see that science-educated people chose them a little bit more. And this is adherence to social distancing guidelines, almost no correlation at all. What correlates with social distancing guidelines? Again, you see here the demographics, the knowledge, and the behavior. And what correlates with them is the gender, is knowledge in the context of COVID-19, is choosing credible sources and health-related justifications. So the other behaviors. You don't need to read this. What you see here is trying to predict self-reported behavior of the entire cohort. This is a model predicting public adherence to social distancing guidelines. Okay, it's really huge because there's all these interactions between group and science education. So you'll have to believe me that the interactions are not significant, and I'll show you a simpler model. What you see here in orange is the significance, or actually non-significance, of science education. So science education alone did not significantly explain any of the variants in adherence to social distancing guidelines. Science education alone did not significantly explain any of the variants in the use of health-related justifications for following the guidelines as well. So the first question was, do people who learn more science make more science-informed decisions? And my answer would be, not really. But we did see that science knowledge plays a role. But what happens when people have other commitments? Do you remember the story about the basketball players? Maccabi Tel Aviv, who came back from Valencia and went to play with Anadolu and flew to Belgrade. You remember the story. So we asked people, do you think the Maccabi Tel Aviv basketball players should have self-quarantined after returning from Spain? So these are the people we asked, right? Really in the beginning of the pandemic. And let's recap for a second, okay? So if science education supports science knowledge and literacy, and they support informed decision-making, then people with more science education or more science knowledge or more knowledge about COVID-19 should understand and support the guidelines to prevent spreading the disease further. Right? Okay, so let's start with what people answered. Okay, what you see here are the people who are not fans of Maccabi Tel Aviv. And 85% of them said, yes, the basketball players should have self-quarantined. What you see here are the fans of Maccabi Tel Aviv. Less than half of that thought that the players should have self-quarantined. But what explains that? So what you see here are the associations about the people who are not fans of Maccabi Tel Aviv, okay? And as you expect by now, science education does not correlate with adherence to social distancing guidelines, but you see the general science knowledge and knowledge in the context of COVID-19 do correlate with adherence to social guidelines, okay? So we see the people that have more knowledge understand the guidelines and they support them. What happens? What happens about people who are fans of Maccabi Tel Aviv? All the correlations go out of the window. Science education, general science knowledge, and knowledge in the context of COVID-19 are completely irrelevant to the question of, do I support adherence to social distancing guidelines. So sports fans, science knowledge is relevant to their stance of COVID-19 guidelines, but only if they don't care that much who wins. This means that they might have the relevant science knowledge, but don't have the right epistemic goal. So they want to win, not to reach an evidence-based decision. These results underscore the relevance of science knowledge when taking informed position on science in everyday life, but also the overwhelming power of motivated reasoning when negotiating COVID-19 guidelines. Let's visit for a second the concept of motivated reasoning. It's really tempting to think that whoever is not agreeing with the scientific consensus or experts are just, anti-science or uninformed. But empirical data do not support this. Where there's a religious or political polarization, like in the case of stem cell research, Big Bang, human evolution, climate change in the US, greater polarization was demonstrated among individuals with more years of general education and individuals with greater scientific knowledge. Greater knowledge sometimes translates into greater capacity and better toolbox to convince yourself that your side is right. Just to show you that it wasn't a one-time phenomenon, let me introduce you to another sample we had. This is a sample of ultra-Orthodox that was collected in March, so just the beginning of the pandemic. So we asked people, do you think the Ministry of Health's decision to close all schools and universities was right? And you can see that only 5% said it wasn't right. So they understood, right? They understood the idea of the basic epidemiology, the basic virology. They understood why it's important not to infect other people, because all the hospitals would fall. They understood all that, right? No. Because when we asked the same people in the same survey on the same day, what about religious schools and seminars? 77% said, no, the Ministry of Health was wrong to close all the religious schools. So I think this is a really good demonstration that understanding science had nothing to do with this, right? It wasn't about understanding epidemiology. Right. So what happens when people have other commitments? Usually the other commitments win, not science education. So I think I depressed you enough. Let's look at the optimistic evidence. Does science education help people identify science-related misinformation? So we're looking at this population of general population from the second wave. You already know them. And we asked, are people relying on misinformation to justify their decisions? So you might remember, we presented people with dilemmas. For example, would you send your child to a kindergarten where staff lives in a city with high positive COVID-19 rate while your family lives in a safe city, okay? And after people decided, we asked them, can you justify what you're saying? So we wanted to see, did they rely on misinformation when they justified their decision? And what you can see here, on the x-axis, this is the highest level of science education, from mandatory to high school to STEM degree. And what you see on the y-axis, this is the percentage of people who actually relied on misinformation. And it's quite obvious that the trend is going down. And this is the same thing also for a second dilemma. Suppose you have an adult parent or grandparent living alone. Will you visit them in coming days? So you see that the responders with higher levels of science education relied less on misinformation when they explained why they're doing what they're doing. What kind of arguments do people use to justify their decisions? Simple ones, broad ones, complex ones. Again, you can see in the blue, the dark thing, this is the simple arguments, okay? And the yellowish ones are the more complex arguments. And you can see again that responders with higher levels of science education used less simple arguments to justify their stance. Let's look at another way to ask the same question. Does science education help people identify science-related misinformation? So what Shaker did, She looked at two of the samples that you already know from the second wave, a representative sample and an ultra-Orthodox sample. And she looked at one of the questions in the survey. The question was, there are many rumors about COVID-19. Tell us about one that you did not believe. How did you decide whether to believe it or not? So first, she took all the things, all the rumors that people wrote, and she asked, can they actually correctly classify them? So when they said, this is a misinformation I didn't believe, was it really a misinformation? So if it was correctly classified, an example would be, I didn't believe that children are less likely to get infected with corona. But some people incorrectly identified misinformation. For example, I didn't believe that it's a virus. And some people just didn't identify anything at all. For example, I did not hear anything. So can people identify misinformation? 55% were able to give misinformation that was actually misinformation. A quarter of the people gave an example of something they didn't believe that was actually true. And the rest, another 20%, couldn't give any misinformation. But can people with very limited science education identify misinformation? So this is from the ultra-Orthodox group. 34% identified it correctly. 36%, so actually more people misidentified misinformation. And another 30% said, I don't recall. What correlates with people's ability to correctly identify misinformation? Gender, no. Age doesn't. General education doesn't. Science education does a little bit for the general population. General science knowledge actually does. And logistic regression shows us that actually people with high general science knowledge were 3 times as likely to correctly identify misinformation. And science knowledge in context was also correlated. Let's look for a second about critical evaluation skills. So we use an analytical scheme for evaluation strategies. Is it first-hand evaluation? Is it true? Second-hand evaluation, whom to believe, or not using any. And you can see that having critical evaluation skills was actually associated with identifying misinformation. People were twice as likely to correctly identify misinformation. So does science education help people identify science-related misinformation? Probably yes. Last piece of evidence. Does science education support lifelong learning? We wanted to see if COVID-19 can serve as a teachable moment for the acquisition of scientific vocabulary. Media coverage can create teachable moments, cases in which media coverage about scientific issues increases public interest in science. While it's a powerful motivator, it is unclear whether teachable moments also lead to actual changes in what people know. So what we did, we took all the content, editorials, and reader comments, published in 2 news websites during almost 4 years. And we searched them for specific 120 science terms. The 2 news sites were the most popular Hebrew general news site with about 120 million words in these 4 years, and the most popular news site serving ultra-Orthodox community with about 28 million words. And we searched for these 120 terms, scientific authorities like CDC and FDA, elementary and middle school like symptoms or oxygen, high school like lymphocyte or antigen, academic like hyperglycemia. And do bear in mind that these 2, high school and academic, are completely elective. So people are not supposed to be knowing them. We looked for them in the general population and in ultra-Orthodox. And this is what we found. The frequency of many science terms increased during COVID-19, both in the media coverage and in reader comments, but more so in the general population news site than in the ultra-Orthodox news sites. You can see it every time. And when we go up and up to the higher level, then people were less likely to be able to learn these new terms. So the teachable moment was more effective for the population that had mandatory science education. Also, the overall frequency of science terms appearances was much lower in the ultra-Orthodox press and comments before COVID-19. But during COVID-19, the frequency of science terms in the press was similar, but readers could not participate to the same level. Again, we see that people that didn't have any mandatory science education were not able to participate to the same level. So does science education support lifelong learning? So it seems. Let's wrap up with implications for science education research. First of all, what is the relevance of science education to public engagement with science? We saw that formal science instruction did not significantly explain any of the variance in participants' adherence to social distancing guidelines or the use of health-related justifications for doing so. We saw that general knowledge and science in the context of COVID-19 played some role in predicting adherence to social distancing guidelines, but this relationship disappeared when other values dominated. One of the main goals of science education is educating scientifically literate people who make informed science-based decisions. But I think this is more a normative statement than a claim that is supported by evidence. On the other hand, science education does seem to have a role in supporting people in identifying science-related misinformation and using it less to justify their decisions, and setting the foundation for lifelong learning, in the words of Brunner, allow us later to go further more easily. So learning science enables people to acquire new vocabulary and use it when needed. And this is really relevant both to the personal and the democratic values of science literacy. I think we should redefine realistic goals for science education in the post-truth era, which are actually informed by evidence from public engagement with science. And we should develop approaches to enhance the coherence between the stated goals of science education and its actual effect on behavior. We should walk this bridge between science literacy and public engagement with science in order to turn these untested hypotheses into actionable evidence. And I think this might help us come up with new concepts like the transferability of science education to adult personal life, with new approaches, for example, performance tasks in the context of public engagement with science, and maybe most importantly, with new research questions. What conditions support the long-term transferability of science education? For what educational goals and for which groups? Thank you very much for listening.
Thank you so much. Now, I'd like to welcome our Honorable Chairwoman again, Mrs. Sibel Erduran, to exchange gifts. I'm so sorry. First, a quick Q&A.
Before gifts, if we have any questions or comments for Ayelet for this fantastic plenary that's getting us to question our assumptions in science education, and also getting us to think about going beyond dichotomies of school science and informal science. I think this was a brilliant set of issues that have been raised and very relevant for our conference. Any questions or comments?
I think there's some. I don't hear.
Other assumptions that we equally need to challenge. Thank you very much. That was great. I really enjoyed hearing a serious critique of some fundamental assumptions that I think may not be justified. I wondered whether you thought where this assumption about science education will lead to science literacy has been challenged. Can you foresee other assumptions being challenged in the area of science education?
Oh dear. But this is a big one. I need to think about this one. Can I think about that?
I think you've given us a lot of food for thought. I mean, it's a really interesting move for us to think about our basic assumptions that we've been operating with for many years. I started thinking about my own work on argumentation and evidence-based reasoning as a way to resolve a lot of those issues that you're talking about, and I started questioning that line of research itself. So I think
maybe what you just said, maybe I have an answer, a small answer for you. You just mentioned argumentation. Another assumption we might have, I'm not sure, is that people actually use scientific arguments in their life, which I must say, from my research, they seldomly do. So I spent quite a lot of time looking at science-related arguments on Facebook, and I didn't see any what you would call scientific arguments here. Maybe there are claims, maybe there are references to things like, I read a paper that, but that's all the information you would have, but not evidence and not arguments based on evidence. So maybe that's another assumption.
Okay. Maybe one more question or comment?
Yeah, I have the microphone here. Yes, thank you. Thank you very much for a very interesting talk. I was interested in your very last slide where you juxtaposed ambition and being realistic. And you said, so maybe we need to be more realistic about what we aim for. And so I was wondering if you could elaborate a bit on that. I mean, do you have a sense from your own evidence or from others working in communication and science public engagement that when you look at the science education literature, you feel certain things are in a way too ambitious or not kind of aligning with the evidence that you're seeing is likely to have an effect? Thank you.
Thank you for this question. As you said when you introduced me, I was a science journalist. And one of the things that really helped me understand where I live was when I was working on TV. I was a sub-editor of a science show. And I needed to come up with a lineup for a show for different people to be interviewed. And the editor called me and said, you cannot do what you just did. You have two people talking about the same thing, one after the other. And I said, what do you mean the same thing? This one is talking about proteins and this one's talking about DNA. And he said, yeah, exactly the same thing. So I think when I'm saying we should be realistic is really to remember the place that science has in the life of non-scientists. And I think we, again, assumption, we assume that it takes much more space than it actually does. If we are serious about teaching people to be citizens using science and not professionals doing science, we should understand what is the real place of science in their lives, when do they use it, how do they use it, and then reverse engineer.
Thank you very much, Ayelet. Could you join me in thanking Ayelet for this wonderful, brilliant presentation and getting us to think.
Thank you so much. Can I have that? Thank you so much.